Okay. Plate tectonics, and here we go. So the Earth is made up of different plates, and we're going to have an opportunity to see a lot of those here. And these plates do different things. They move all around, clearly. We used to have Pangea many millions of years ago, and it was one supercontinent, and it has since broken up. And believe it or not, it's done that many times throughout Earth's history. So right now, we happen to be in where we have all these different continents separated by ocean. We have the Pacific Ocean separating the United States from Asia. We've got the Atlantic Ocean separating the United States from Europe, and that's how it affects us, but it used to all be together. And so we have these plates will move in different directions, and they'll usually move apart, together, or they'll slide side by side. Today, we are going to talk about the convergent boundary, and to understand the word convergent, you need to look at the definition, and convergent means to come together. Like defensive coordinators teach their football team to converge on the football, meaning everyone go towards the football. So when we're talking about convergent boundaries, we're talking about plates moving together. So let's look at this top one here. There's an example of continental crust moving towards continental crust, creating a mountain range, kind of like the Himalayan mountains in India. And then over here to the graphic to the right of it, we have an oceanic plate here moving towards an oceanic plate here, and you can see that island arcs can form, kind of like the Aleutian Islands. We'll talk about that. And then over on this side, we have the oceanic crust coming up and against the continental crust, creating a mountain range, a volcanic mountain range here, kind of like the Andes Mountains in South America. And here's another island arc here where in this graphic here is an example of this phenomenon here, what's going on in the plates. You have one going underneath, and then you have plate melt happening, and it creates magma, which creates more land, which eventually pops out of the water and creates islands. So let's deep dive in and learn more about convergent boundaries. Again, coming together, converging, two arrows pointing towards each other, two plates coming together, like so. And they collide, essentially. So, when Pangea broke up, there was a piece of Pangea from the bottom, that actually came up India. It came up from the bottom of Pangea and it essentially smashed into the Asian plate. And it's still colliding together as we talk right now. The Andes Mountains are higher today than when you or I were born. Not by much, but that plate is still converging into, those plates are still converging together, and that convergence creates higher, more elevated mountains. As you can see, they crumple and fold and get higher and higher. Earthquakes are very common at convergent boundaries, where two tectonic plates collide. I'll show you a graphic later that shows you, worldwide, the areas of convergent boundaries and where earthquakes are active. But yeah, absolutely common. So when two plates come together, one usually is more dense than the other. And the one that is more dense will sink below, and that's a vocabulary word we call subducting. So as you can see here, I'll move the mouse over, you can see the lithosphere moving this direction, and because it's wet plate, wet is more dense than dry, wet plate will always subduct And so that wet plate goes to subduct down, and as it goes to subduct down into the asthenosphere, it melts and rises up. And so this crumpling mountain range that's happening because of this convergence will turn into a volcanic mountain range, because there will be melting of that subducting plate will come up and have, volcanoes. Just like so. Subduction. And, they call that area subduction zone. And that's where it goes down. As you can imagine, it gets really deep in these areas right before the continent. Where the oceanic plate will go down, it gets really deep. There's some, wildly famous trenches that are right near these areas or places of land. And it's really deep parts of the ocean. Yeah, so another slide explaining that. Definitely understand that term trench and subduction. And again, the Mariana Trench right here. So you got Australia and New Zealand here, and Asia and Japan over on this side, but this is where that trench is, because this is the oceanic plate that's moving this way and the continental plate colliding. And this collision has created this very, very deep trench here. And it kind of shows you some perspectives of where the Titanic sits, how tall Mount Everest is, and then how deep the Mariana Trench is. So yeah, it kind of just talks about it. As the more dense plate sinks, it begins to melt. This melted rock, called magma, rises to the surface. And depending where they are, or depending where that happens at, that's the geological feature that it will create. If you have a continental plate here, it creates a volcanic mountain range. If it happens here where you have oceanic plate and oceanic plate, the more dense plate will subduct, and then the magma will come up and form volcanic islands in these areas, not to be confused with the Hawaiian Islands. Hawaiian Islands are because of a hot spot, not because of a convergent boundary. So that is not the same, and I'll talk about that at another time. The rising magma creates volcanoes throughout the entire, mountain range. We've already talked about that. Andes Mountains, great example right here. South America, just south of us. Yeah, volcanic arc. Volcanic arcs are the sign that subduction has occurred. Yes, again, the Aleutian Islands up there by Alaska. Oceanic plate coming together, and this is the magma coming up, and finally it pokes out of the water, and that becomes land, goes through primary succession, and eventually becomes habitable land sometimes. Yep, more island arcs. Fun fact, right there, Guam, I used to live there. Yeah, back in 1970s, that's right. And here it is, part of the Mariana Trench. And that's the end of that. I'm sharing you a website as well. This website right here, amazing, a lot of cool pieces of information coming from this site. You can see the Earth here, and it's broken up into big plates. And these plates are where a lot of these interesting geological features, where they happen. So you have this Pacific plate, and you have the North American plate, and there you have ocean here and ocean here, and they are colliding together, and that's the Aleutian Islands right there. There's the Hawaiian Islands. Do you see? No plate nearby. So the reason why, or no boundary nearby, sorry. The reason why those are formed is because of a hot spot. It's a thinning in the plate where magma can pop out. And so as the plate kind of moves, that's how the mountain range is created, the underwater mountain range. So the big island of Hawaii, right there where the finger is at, that's the active volcano, and all the islands behind it are no longer active because the plate is moving that direction. So there's actually a bunch of Hawaiian islands that are underwater now. They've been weathered and they're no longer sticking out. So pretty interesting. But you can see these plates and lots of things happen here. You can have volcanoes and earthquakes, different things like that. This is the Ring of Fire. So let's scroll down here. This is kind of what happens, what causes the plates to move in the lithosphere. We have that convection that's happening, heat rising, that magma rising, and then dragging across, dragging the plate, and then going back down again. So as it will move in this kind of fashion, the plate will drag this way, and as it moves this way, clockwise, the plate drags this way, and then we have this thing called an Atlantic ridge or a ridge, a mid-oceanic ridge that will happen, and I'll talk more about that during a divergent boundary. But Ring of Fire right here. Lots of activity happening in those areas. Here you go. This is a great picture. Earthquake activity. Look at the Ring of Fire and the boundaries. All this activity. We have earthquakes, and as we know, we have the volcanoes in the Andes, in the Aleutian Arc. So where those plates come together, there's a lot of action, a lot of activity will happen. But for convergent boundaries, you have subduction, you have trenches, you have volcanoes. Those are the top three things that happen at a convergent boundary, and it can happen at continental coming together, just like over here. Where are we at? In India, the Himalayan mountains, oceanic, continental, Andes, or you can have oceanic, Aleutian Arc. All those things can happen at those areas. So that's the end of the convergent boundary information.